Welcome to Web Handling. My name is Dave Roysum. More than 5,000 people have taken my award-winning and trademarked Web 101 course. I have some 60 hours of video-on-demand training, including my Web 101 courses, as well as 400 free clips titled Web 201 through Web 501 on this all-web handling channel of YouTube. Yet, of all that I teach, this condensed version of my wrinkling module could be considered the very most important. The reason is quite simple. That is, wrinkling in all of its forms may be the most costly defect in the collective web handling industries. It is often in the top 3 causes of waste, delay, and customer complaints in many plants. It will, at times, trouble almost all webs on almost all machines. If we ask someone what kind of wrinkle they have, we will get some very, very unhelpful language, such as baggy webs, buckle, crease, fold over, gather, pucker, trough, hard wrinkle, soft wrinkle, and so on. We need a definition that can pull all types of flatness issues together to provide a foundation for the entire subject. That definition is quite simple. Anytime a web is not as dead flat as a tabletop, we will let QA and customers define their own threshold of pain for severity. The troubleshooter, however, should be able to look much, much closer to see wrinkles long before severity rises to the level of complaint. Another bit of cleanup required to start is to note where the web is not dead flat. We will use a roller-oriented language for 2 reasons. First, the rollers may be the root cause of wrinkling because they are not good enough in some specific way. Second, even good enough rollers may kick off wrinkles on a web where the web is not good enough in some specific way. Stay tuned for the details. Once we identify the specific roll that initiates a specific wrinkle, we can make a useful distinction based on location. One language is that a trough is a wrinkle in the web span just upstream of the roller. This is where the troubleshooter can get ahead of the problem by seeing the risk and the root cause long before anyone complains. If the troughing is too severe, a bulge or crease may form on the roller, in which case almost all webs are damaged, if not rejected. I have a Web 401.22a through F mini-series on YouTube that shows you how to better see wrinkling before it runs into the level of complaint. There are 2 places where you might look for wrinkles. The first place is in situ, specifically the specific roller that initiates a specific wrinkle type. This location is best for troubleshooting machine or process insults. However, it is not great for separating material from machine problems that might well occur together at the same location. To separate machine insults from material flaws, you may have to take the web out of the machine and lay it on an inspection table as shown in the photo. This is especially good for troubleshooting bagginess. What if all you have is a customer return? You can get started by diagnosing type and possibly subtype, as given in the next slides. You can also diagnose the root cause if you've seen precisely the same character at the end of your own line. However, just because you can diagnose a problem does not necessarily mean you will be able to fix it. Also, you will not be able to diagnose, much less fix, a problem whose source is on the customer's machine. The only option you have in that case is to buy an airplane ticket and see your customer's process, if they let you. If you are not allowed to visit the customer, then I would not waste any further troubleshooting effort on that problem and pay or not pay the claims as you see fit. But don't make any further promises with regard to fixing the problem. Now, after those preliminaries, we are now ready to start troubleshooting. Yippee! It is a two-step process where we first determine major case and then subcase. These 6 major cases comprise 99% of the wrinkles you will ever see. You can tell which major case you have literally at a glance and within seconds. The MD, the diagonal shear, and the baggy web will be 90% of all wrinkles you will ever see. So we will cover those briefly here. The remaining 3 types are detailed elsewhere. The MD wrinkle is easily distinguished from other major cases because the trough, the bulge, or crease is oriented very close to the machine direction. All of the subcases have to do with width. You must always take one more step with wrinkling, and often as well take one more step in other web and winding defects. That is, to go from major case, which can be seen at a glance, to subcase, which some people might refer to as root cause. Here is a very complete list of MD wrinkle root causes and corresponding cures. With a bit of study, you will see that all subcases involve web width changes. Most of these subcases can be easily eliminated by what you already know. For example, if the wrinkle you are studying is not formed in a coating head or an oven, then the root cause is not expansion due to moisture or temperature. Summarizing the machine direction wrinkle. The wrinkle is oriented in machine direction because the root cause has something to do with width change. Your options are simple to list, though not always pleasant to do. First, you determine the remedy suggested by the root cause or subcase. For example, if the web is wrinkling due to heat, then turning down the oven temperature must be considered. If the boss or customer or product developer says no to turning down the heat, then your only other possible effective and possibly pleasant option is effective spreading immediately after the point of expansion. Otherwise, you will just need to redesign the product or process or live with wrinkles. There you have it. Super simple to diagnose and super simple to list all options suggested by physics. The diagonal shear is extremely easy to begin with. The major type is recognized at a glance by the wrinkle being at an angle. In fact, the mechanics-based severity of the wrinkle is the angle. The diagonal shear wrinkle is also easy to understand what connects all of the subcases together, namely something, web or machine, is crooked. Your job is to figure out precisely which one element is crooked in what specific way that is responsible for that wrinkle originating at one specific source. The problem then gets much harder because while there were less than a dozen subtypes for the machine direction wrinkle, the number of ways of getting something crooked and causing a shear wrinkle may be uncountably large. Still, shown here are just few of the many ways that something can be crooked. Perhaps the most common is simple in-plane roller misalignment, which my Web 101 students will know all about. Another common source is uneven nips, which can be in turn caused by many different ways, as covered in detail in my Web 101 course. So, you first try and pinpoint precisely what element is crooked in precisely what way. If you're sure you found the root cause of crookedness, then fix it if you can. If you do not absolutely know for sure what is crooked, then start on your own machine first. Roller alignment and diameter profile are two things to check for with rollers. Nip pressure via nip impression or other technique should also be checked if the wrinkle originates just before, at, or just after a nip. Finally, if you have moisture or temperature changes, make sure the coating or temperature profile across the width is level and uniform. To summarize, note that the wrinkle is at an angle. Note that all subcases have to do with something being crooked. Find out specifically what is crooked and then fix it if you can. If you don't know for sure what is crooked, check the machine geometrical precision in that specific area where the wrinkle originated. Baggy webs are a very common cause of complaint. Baggy webs are extremely easy to recognize by appearance alone. Recall, however, that the safest and surest way to do so is by taking the web out of the machine quite carefully and try and avoid adding new wrinkles in the process, and then put that web on an inspection table with good lighting. The reasons that bagginess is such a great cause of complaint is that it can cause many different issues on your machine, on your customer's machine, and or in end use. Still, however great the desire to remedy, you must give this defect a special level of respect. Bagginess is easily one of the most difficult problems to troubleshoot and can be difficult or sometimes economically impossible to fix, even if once you have identified the root cause. One of many reasons for the troubleshooting difficulty is that quantifying the severity of bagginess is difficult. The strip test is one of the few measurement methods that works for many, if not most, situations. While quite useful, this test is extremely tedious. It is true that there are other measurements of bagginess. However, most are problematic in most situations. Thus, you can see the challenge for the troubleshooter who wants trials is the challenge of measuring the result. Most things don't work in any situation, and those that do work will be tedious. While direct measurement of bagginess can either be tedious or ineffective, or both, there is another method to consider for certain materials, such as most paper grades and some films and some other materials. That is, there can be a very strong connection between bagginess and wound roll hardness variation, such that it can be used to predict runnability in a machine or screen incoming wound rolls. Always, my first piece of advice for baggy webs is to avoid the assignment if you can, because this problem has a failure rate bordering on near certain, especially if you don't have a background, which I will share with you shortly. Still, we may be assigned the problem, and then we'll have to make a suitable effort. While I generally hate recipe-based troubleshooting, the steps here may give you a place to start. If you are assigned bagginess, I strongly urge you to view all of a couple dozen successful troubleshooting case histories given on my Baggy Web series, Web 201.45a through F. Look there for not only some causes found in the various web industry, but more importantly, for the tools that the successful troubleshooters use for this problem. There are many ways to make bagginess. However, the very most common is winding of a web that has a thickness profile variation across the width. It does not matter if you don't know how to make the web more uniform in manufacturing. It does not even matter if you can't even measure the thickness variations that are responsible. This is no surprise because the variations that are responsible are tiny, typically on the order of 1 to 10% of the web's thickness, and that may be below measurement resolution for thin webs. All that matters here is that the winder concluded the web was not level enough. While thickness variations are responsible for nearly all film and foil bagginess, paper and other complex constructions have other ways to make bagginess that are not related to thickness profile. Baggy webs are lanes of tightness, looseness, or sometimes patches. They're caused by some specific component that is not uniform in some specific way. Avoid this problem assignment if you can. If not, see my Baggy Web troubleshooting series on YouTube. Auditing wrinkles is easy once you've improved the lighting and trained your eyes to see better. There are other techniques to make your inspection more sensitive. Start upstream, where the number of individual wrinkle types is less, and work your way downstream. Note which roller initiates a specific wrinkle. Make a sketch of the wrinkle position, orientation, and pattern. Use what we've just learned to make a working theory for each wrinkle initiation location. Once you've tested that working theory to be near certain of wrinkle type and subtype, the wrinkle subtype will be the root cause and have associated with it a remedy list unique to that subtype. For your convenience, I have listed the 20 most common types of wrinkles, which will comprise most everything you will ever see with regard to flatness problems. We even have a free and easy internet app, the Wrinkle Troubleshooter, that can guide you through the troubleshooting tree. Wrinkles can often be super simple to diagnose once you've trained your eyes to see in new ways. The orientation of the wrinkle will give you the major case. The subcase is the root cause. Locate the initiation point in the machine. List all remedies suggested by the physics of that subcase. After that, you are ready to decide which remedy option to pursue and will do so with a good likelihood of success. I know this was a bit rushed, trying to do 2 hours of wrinkle instruction in 20 minutes, but you've got the essence here. Also, you can play back this recording or turn to hundreds of other publications on wrinkling, as well as a related topic, and that is spreading. Thank you so very much for allowing me to share some of the best that web handling has to offer on this, a most important topic, and that is wrinkling. Let me know if you have any questions, or if there's any other topic you would like to hear about. See you next time.